Okay, now we're back to page 95 of your workbook, section 8.5, experiments. We're going to wrap up the chapter 8 with this last part of the videos, and I will include some excerpts from the PowerPoint. What I want you to do in the workbook here is do them mainly as classwork. So then go back and check your answers. I'll show that after I go through the PowerPoint. So we've discussed observational studies, but also we want to look at how experiments might work. Observational studies are based on observations or measurements, but an experiment is where the effects of a treatment are measured. A treatment is applied to the subjects of the experiment for a duration and then measured during the course of the treatment. So that's all right here. So I'm going to pull in the PowerPoint now. And then after I do this, pause the video and do some of the questions. So here's the resource I'm using. I will post these slides at the end of the video set. You do not need to take notes on everything, but do jot down some specifics. I might point out some things you might want to note. Collecting sample data. So the method used to collect sample data influences the quality of the statistical analysis. Really important is the simple random sample. We've talked about that a lot. So if they are not collected in an appropriate way, then the data may be so useless we don't want to even bother. Gold standard is randomization with placebo treatment groups. It's called that because it's so effective. A placebo, such as a sugar pill, has no medicinal effect, but we all know sometimes we think something's going to help us, so then maybe it actually does work. But does it work for everybody? And is that treatment, is the medicine actually really that much more effective than nothing? Because we want to minimize use of interventions if we can. So collecting data, we have observational studies and experiments. Experiment, we apply a treatment. We just talked about that a minute ago. A lot of times they're called experimental units, often called subjects. Observational study, the key thing is you're just watching or measuring without modifying what they're doing. There's no intervention, no change. You're just recording down what's happening. Observational study, observe past data to conclude that ice cream causes drownings based on data showing that increases in ice cream sales are associated with increases in drownings. The mistake is to miss the lurking variable of temperature and the failure to see that as the temperature increases, ice cream sales increase and drownings increase because more people swim. So that would be a confounding or just a misinterpretation of the data. Also, if there's a correlation, which means there's two trends that are kind of the same and they're seem related, it doesn't necessarily mean one causes the other. An experiment, to conduct an experiment with one group treated with ice cream while another gets no ice cream, we would see that the rate of drowning victims is about the same in both groups, so ice cream consumption has no effect on drownings. Here the experiment is clearly better than the observational study. So in an experiment, you can really differentiate the two things. Replication is the repetition of an experiment on more than one individual. If you listen to podcasts, I listen to a lot of podcasts on like health and fitness, and they always talk about the N of 1. I mean, it might work for somebody, but N is typically the variable we use for our sample size. It really should be 30 or larger for good data. Blinding is a technique in which the subject doesn't know whether he or she is receiving a treatment or a placebo, Blinding is a way to get around the placebo effect. Double blind is when also the experimenter doesn't know. Randomization is used when subjects are assigned to different groups through a process of random selection, and we talked about this previously, so I'm not going to go into too much detail with this. We talked about systematic sampling, convenient sampling, stratified, cluster, multi-stage. Observational studies measure but do not modify. So sometimes we look at cross-sectional studies that data are observed, measured, and collected at one point in time, not over a period of time. So it's just one-time thing. We're looking at it not like for years. Retrospective is when you're looking back in time. Prospective is you're looking at something, you start like a cohort. We do that a lot here at SBSCC. We might look at a particular population group or type of student and then see how they progress throughout their time here. Confounding occurs in an experiment when the experimenter is not able to distinguish between the effects of different factors. Try to plan the experiment so that confounding does not occur. There might typically be some, but you want to try to avoid that and at least note it in your conclusions. Controlling effects of variables, completely randomized experimental design. Assign subjects to different treatment groups through a process of random selection. Randomized block design is a block is a group of subjects that are similar, but blocks differ in ways that might affect the outcome of the experiment. Matched pairs design. Compare two treatment groups by using subjects matched in pairs that are somehow related or have similar characteristics. And rigorously controlled design. Carefully assign subjects to different treatment groups so that those given each treatment are similar in ways that are important to the experiment. Now that gets into a little more than we're going to do in this course, but just so you are aware that you can try to avoid those confounding things. Sampling errors. No matter how well you plan and execute the sample, there's likely to be some error. Sampling error occurs when the sample has been selected with a random method, but there is a discrepancy between a sample result and the true population result. Non-sampling error is the result of human error, including such factors as wrong data, computing errors with biased wording, or questions with biased wording, false data provided by respondents, forming biased conclusions, or applying statistical methods. So we talked about that before, these other things, but applying statistical methods that are not appropriate for the circumstances, we didn't talk about that yet, but sometimes we'll see that in the next section, or chapter 9, that just you've got to fit in the right way to display the data, to crunch the numbers, choose something that's appropriate. Non-random sampling error is the result of using a sampling method that is not random, such as a convenient sample or a voluntary response sample, and those are pretty typical errors. And that is it for the PowerPoint. Now if you pause the video and work out the questions, see if you can, figure those out on your own. Okay, so here's the answer to example 8.10. A is observational, B is experimental. The treatment would be jumping jacks, and C, experimental treatment is coffee and tea. I'm going to scroll up. 8.11, it depends. The subjects could have exercised or eaten less based on what other directions may have been given with the pills. In your book, they have that same problem with more details along with it, that things like, there was fine print that there was, you have to not eat after 7, or you have to eat 3 small meals, or something like that, that would actually cause a calorie deficit. Let's see. 8.12, placebo could be a similar looking sugar pill. B is got a typo, I gotta fix there. Non-alcoholic beer could be given with a control group. Treatment group could be given diet meals, kind of looking the same. You could have maybe had a variety of things. This is just what was in the, a lot of these come from those You Try It problems in the textbook. So that's just some of the standard answers. And here's the last one, 8.13. To test a new lie detector, 2 groups of subjects are given the new test. One group is asked to answer all the questions truthfully, and the second group is asked to lie for one set of questions. The person administering the lie detector test does not know what group each subject is in. Does this experiment have a control group? Is it blind, double blind, or neither? So the truth-telling group, you could think of that as control, but really, actually, both groups are kind of having an intervention, because one's told to, tell the truth, and one's told to lie a certain amount of times. So that because this lie detector has to correctly identify lies, but also not to identify truth as lies. You don't want like a false positive. This is a blind study, since the person running the machine does not know which group a particular subject is in. But the people in the group do know, because they were told how to answer one way or another. So that's it for Chapter 8. I'll post the solutions next, but I think you've basically had everything in the video. So just want to make sure that you double check things. If you wanted to print the answers, that's up to you. I'll make sure I go and fix my typos. Have a great day.